Hello, so my name is Jazz, and we're going to be discussing projectiles. I'm also going to be watching the Iowa caucuses. Refresh. Okay, nothing has changed. That's okay. This is Charlie Brown. He doesn't understand projectiles. And maybe it's because he never actually gets to kick a football himself. Anyhow, a projectile is an object where gravity is the only force, and hence vertical acceleration is negative 9.8, and horizontal velocity is constant, hence horizontal acceleration is 0. This is the force diagram for basically every projectile, because you can see there's only gravity and no other forces acting upon the object. So what does this mean? This means that acceleration vertically is going to always be negative 9.8, and whether it's a football or a bullet, it's the same acceleration. And x is independent of the y-axis. This is basically saying that mass does not change gravitational acceleration, and we can show in cancellation of mass in the equations using Newton's second law that F equals ma, that we can say mg equals ma, g equals a. Mass does not create any change in vertical acceleration. So here we have all of these force diagrams with the same arrow. They're all the same sized arrow because gravitational forces are acting upon them at the same amount of acceleration despite the different masses. Even this football versus this bullet, even though there's a different horizontal velocity, because horizontal velocity does not affect gravitational pull, they still have the same size arrow. So we have three main physics problems for this unit. Here's one of them. But first, the caucuses. Oh, that's pretty close. Okay, well, here we have Snoopy. This is a type 1 problem because he's taking off from the edge of a cliff on the fact that he can somehow manage to fly his little doghouse, and he takes off with 250 miles per hour, or meters per second, at a height of 75 meters. So, a few things to note about this problem, which will be the same for every type 1 problem, is that initial velocity is going to be 0, and this is because vertically he's not moving at the start. Initial velocity for x and final velocity for the x is going to be the same because acceleration is always 0. Meanwhile, we were given that delta y equals negative 75 and acceleration negative 9.8 as I explained earlier. So we're going to try and figure out how long will it take, how far out will it go, and then what's the velocity right before it hits the ground. So the best method for solving these kinds of questions, that is true for all projectile problems really in general, is you want to solve for the y-axis, get as much information as you can know, and then solve for the x-axis. So with the y-axis, we're attempting to find time, and here we're just doing simple kinematics. It's really just plug and chug, where we're using delta y equals v naught t plus half at squared. The negative sign is something important that some students often forget, and your resulting total will be that time is 3.91 seconds. So how long will it take? We've already been able to answer that. It's 3.91 seconds. This is the amount of time that it takes Snoopy to go down and crash. Now, delta x equals v naught t. In case you're wondering where I got this equation, it's actually our second kinematic equation. This is just the result of what happens after we have a zero acceleration. Using t, which we found now is 3.91 seconds, and given that initial velocity is 250, we can simply plug and chug and find that delta x is equal to 978.08 meters. Now the last question, this answers how far it will go. The last question is going to be, what's the velocity right before it hits the ground? So that's solving for the vertical y velocity, final velocity. And here we use our first kinematic equation where v equals v naught plus at. That gives us negative 38.32. And you can actually also use v squared equation, and you'll also get the same answer. I did check that. Yeah. I'm gonna pause.